Okay, so we still have a couple more geometry sections to get through, and they should be friendly-ish. Section 2.2 covers two topics, but they're reasonably simple topics, perimeter and area. And I'll just kind of just jump into it and see what happens here. So the perimeter is the length of the edges of a two-dimensional figure, and if it's a circle, the perimeter is called circumference. There's formulas to find perimeter. You don't really need a formula to find the perimeter of if the figure has straight line edges. If a figure has curved edges like a circle, then you need a formula to find the perimeter of it. And if a figure has wiggles to it, you need calculus to find the perimeter or the length of that. So there's just a picture here that gives me a rectangle, and I could find the perimeter of this rectangle by just adding up the lengths of the sides. So I just started with one of the sides and worked my way around the rectangle. So I had a side at 7, 3, 7, and 3. I added the sides and I got 20. Notice these figures don't have any units attached with them. Usually when we have lengths, we attach units like inches, feet, centimeters, meters, kilometers, but this doesn't. So I should probably, in this work up here, write the perimeter is 20 units. Whatever these units are, could be inches, feet, meters, centimeters, millimeters. We should usually have units with a perimeter answer, and it's not going to be square units. You get square units by multiplying, and we didn't do any multiplying here. There's a formula to find the perimeter of a rectangle, which we'll learn quickly here, and we'll revisit problems like this with a formula. But honestly, it's not that important to have a formula for perimeter, because as long as it's a straight-edged figure, you just add up the lengths of the sides to get the perimeter. So here's another example. There's a pentagon that has 5 sides, and it's a regular pentagon at that because all the sides are the same length. In a pentagon, the sides don't all have to have the same length. But if I just take the 5 sides, each of which are 3, and I add them up, I get 15. Another way to do this is there's 5 sides, each times 3. That will also give me 15. And again, I should probably attach some sort of length or some sort of unit to the unit of measurement, when I say unit, to the answer of what the perimeter of that pentagon is. So in here on this page, I just say yes, there's a bunch of formulas for perimeter, and as long as the shape has straight edge sides and not curved sides, you don't really need a formula at all. You can just add up the sides. But for a circle, to find the perimeter of a circle, which is called the circumference, you need a formula, and we'll learn the formula. And I generally don't make you remember formulas, so I'll give them to you on the test. So here are just some basic perimeter formulas. For a triangle, in the last section we worked with right triangles. For the perimeter of a triangle, it doesn't matter whether it's a right triangle or a non-right triangle. Whatever the lengths of the sides are, you'll add them up to get the perimeter. In a square, because all the sides in a square are the same, then you could, to find the perimeter of a square, if you call each side A, you could add up the 4 A's, and that would be a completely legitimate way to find a perimeter. But this can be simplified because A plus A plus A plus A is really the same as 1A plus 1A plus 1A plus 1A. The coefficient in front of the letter is 1 if none's written. And so if you add A plus A plus A plus A, or 1A plus 1A plus 1A, you get 4A. There's a times sign between the 4 and the A that you don't really need, but I'm just emphasizing that you could find the perimeter of a square by just taking the length of one of the sides and multiply it by 4. For a rectangle, it's kind of interchangeable, what you call the lengths in a rectangle. Well, one of the sides is usually called the width, and the other side is interchangeable, called the length or the height. And I, depending on what I decide to call the sides, I think I'm probably more used to using length and width for a rectangle. But since there's going to be, in a rectangle, there's going to be two sides that are called widths, and two sides that are either called length or height. And if I add the four sides up, if I add this side plus this side plus this side plus this side, this is really 1W plus 1W plus 1L plus 1L, which is 2W plus 2L, which is a completely fine formula for the perimeter of a rectangle. Or you can factor out a 2 from this. And if you factor out a 2, you get the formula, well, you get something that's equivalent to the formula that I have here, 2 times the width plus the length. Basically, to find the perimeter of a rectangle, you add the non-equal sides and you multiply by 2. For a quadrilateral means a figure that has straight edge sides, but 4 of them. You just add up the 4 sides, so the sides, whatever they're named, you just add them up. For a circle, you need to know the radius of the circle, and a radius of a circle is the distance from the center of the circle to one of the sides, so you need to know the radius. And the formula for the circumference of the circle is 2 pi r, and we will interchangeably leave pi at pi, or from time to time, if we need a decimal approximation, or if we're asked for a decimal approximation for pi, we'll use 3.14. Our calculator has a pi button somewhere, and I believe that's the pi right there on the exponent key. If I wanted to get my calculator's version of pi, I'd hit the second button, and then I'd hit the exponent key, and there's the symbol pi, and then when I hit enter, it gives me that version of pi, which is maybe about 10 or so decimals. Pi is an irrational number, and my calculator gives me, a handful of decimals, but pi has infinitely many decimals, and the pattern never repeats. There are people that will run supercomputers for days at a time to get tons of digits of pi. I'm not really sure why, but there's literally people that have like a room of like paper that has just all the digits of pi that they've come up with, which I don't know why, but people are into that. Alright, so those formulas I'm going to keep handy. Now I'm going to do some problems, and I'm going to put units in my answer now. So, first example, find the perimeter of this rectangle. So for a rectangle, I don't know how well you can read these, the sides say 4 yards, 4 yards, 7 yards, and 7 yards. Usually I'm going to leave the units off and just throw them in my answer when the units are just linear. And so my formula for perimeter is 2 times the length plus the width. And it doesn't really matter which side you call the length and which side you call the width. It's probably most common to call the length the longer side and the width the shorter side. But the perimeter of any rectangle is just 2 times the sum of the sides. And if I put units in, it makes my work a little bit harder to read, but it's not a bad idea. The thing is, when you're adding units, you don't get square units. It's when you multiply yards times yards that you would get square yards. So if I put my units in, then my work's harder to follow. I like to just put them in at the end, but it's okay to do your work with the units. When you're adding units, they stay. So 4 yards plus 7 yards is 11 yards. And now 2 times 11 yards is going to be 22 yards. I'm using the letter P for perimeter, which is super common. So the answer to this, the perimeter of this shape, is 22 yards. And it's real important, it shouldn't be square yards. So units, in this case yards, are not squared in perimeter problems. on the test, I'll ding you a point if a problem has units and it wants units in it and you don't give me the units, or if you give me the incorrect units. Next example, find the circumference of the circle, and if it doesn't say use a decimal for pi, then I'm going to leave the symbol for pi in my answer. So I need the formula. The formula for the circumference of the circle we had on that formula sheet is 2 pi r, and r is the distance from the center of the circle to the side, and it could be any line that goes from the center of a circle to the side. They're all going to be the same. The units on this are inches. If I put the inches in my computation, it's okay. They need to be in my answer. So that's the formula, and to simplify this formula, I'm just going to multiply the 2 and the 5, and I'm going to leave the inches at the end. So the circumference of this circle is 10 pi inches, and I'm going to leave it like that because it doesn't say to write my answer in decimal form. In some of the problems, if I ever want the decimal form with the 3.14 version of pi, I'll tell you. And so you'll see I write my answer down here like this, and rather than writing C for circumference, I spelled circumference out. It's probably better just to write C. And then you have your flexibility. If you want to use a symbol to represent inches, you can. If you want to use an abbreviation to represent inches, you can. Or you could even say, if you want it to get really wordy, you can say the circumference is 10 pi inches. Probably when I abbreviate, I probably should put a period after the inches, but I didn't, and it's hardly that big of a deal either. I'm definitely not grading your English skills. Okay, so now some just simple homework problems. And for 1 through 4, it says find the circumference of each circle. Make sure to leave you include the proper units. So in my problem number 2, my units are going to be centimeters. I probably I'm not going to show them until I get to my answer. When you do problem 1, your units are going to be meters. So for me, for number 2, and you can try number 1 simultaneously, the circumference formula is 2 pi r. I'm going to say circumference is 2 times pi times 6. And for my answer, for problem 2, I'm going to use C for circumference. I'm going to multiply the 6 and the 2 and get 12. I'll have the pi, and I'm going to put my units. And my units for all perimeter problems are linear. They don't have exponents. I'm not going to get square or cubed units for a perimeter. 3 and 4 give me not a radius, it gives me a diameter. So in problem 4, I need to figure out what the radius is. If the distance all the way across the circle is 3 yards, if I divide that by 2, I'll get a radius, because a radius is half of a diameter. And for your problem, you have the diameter, which I usually denote as D, is 16. A radius is always a diameter over 2. So if you take 16 centimeters and divide it by 2, when you do your problem, your diameter, your radius is going to be 8 centimeters. So use the same formula now. Circumference of a circle is 2 pi r. So the circumference is 3/2 is 2 pi times 3/2. And then I'm gifted enough that I could do these fractions fine. I could just multiply the 2 and the 3 here, because the 2 is really 2 over 1. And to multiply this, I can go 2 times 3 is 6, leave the pi up top, and in the denominator, 1 times 2 is 2. So that would give me 6 pi over 2. The 6 and the 2 cancel, are going to leave me with 3 pi. And I'm going to attach my units back, which are yards. I could have at the beginning too just canceled the 2's and got 3 pi cleaner. Your problem doesn't have the fractions that you have to deal with. Okay, 5 through 12, perimeter problems of just nice standard shapes. And the formula I'm going to use for the perimeter in number 6, the perimeter of a rectangle, is twice the length plus the width. I'll put my units in my computation, but I could just put them in at the end. My answer are going to be centimeters. It doesn't matter when I do problem 6 if I call the length 4 or I call the length 10. You'll get the same answer if in your parentheses you flip-flop the numbers. Orders of operations tell me I have to do the parentheses first. Inside my parentheses, 4 centimeters plus 10 centimeters is 14 centimeters. And then 14 times 2 is going to give me 28. So my answer to problem 6, the perimeter of my rectangle is 28 centimeters, and you can figure out what yours is. 8 is a parallelogram, and I didn't give a formula for a parallelogram. And in a parallelogram, I'm assuming that any internal lines have something to do with the area and nothing to do with the perimeter. I'm also assuming that the opposite lines have equal lengths. I don't have an area formula for a parallelogram, but it doesn't matter. So those are the 4 sides I'm going to use for my perimeter, and these will be the 4 sides you'll use for your perimeter. The number internal is called the height, and it's not one of the edges. This is called, I can't read it anymore, but it doesn't matter, you don't need it for this problem. This is called the height, and it's internal, it's not on part of the perimeter. For me, this 5 centimeters is called the height. You need that for the area, but not the perimeter. I'm going to assume that the opposite sides have equal lengths, and it tells me in the instructions to do that. And so my perimeter for number 8 is going to be 7 plus 15 plus 7 plus 15. That's going to be 44. And then I'm going to attach my units, and I'm going to say the perimeter is 44 centimeters. Nine and 10 are triangles. To find the perimeter of a triangle, you just add the 3 sides. You put the units in your computation, or you could save them to the end. But your answers have to have units. For my problem 10, I get 28 for the perimeter, and I'm going to attach the units of centimeters. Your triangle is an isosceles triangle. Hardly matters. All you have to do is add up the 3 lengths to get of the sides to get the perimeter. 12 is a trapezoid. Your trapezoid doesn't have a height shown. Again, the height is something I need to find the area of a trapezoid. Like I needed the height to find the area of a parallelogram. But this height, the internal line that connects the sides, is not part of the perimeter. So for my perimeter in number 12, I'm going to say the perimeter is 20, I'll put the units on, centimeters plus 12 centimeters plus 6 centimeters plus 16 centimeters. And that's 20, 30, 40, 42, 54 centimeters. Hopefully yours is readable. Let me blow it up a little bit just in case you couldn't pick out the sides were 3, 4, 5, and 8 inches. So that's it for perimeter. That's the easier of the topics in this lecture. And then area is the next, and area is not that particularly hard. So the area is the amount of space a 2-dimensional object takes. If we get to 3-dimensional objects, we talk surface area, or you talk volume, but we're in 2-dimensional objects. And 2-dimensional objects, if we want to find out how much space they take up, we use area. And the first example says find the area of a 4 by 9 rectangle. And so if I had a rectangle that was 4 units by 9 units, and I divided it up into, vertically 4 units. So I took those 4 units and made them all into 4 1 units. And if I did horizontally, divided the 9 up into 9 units, so broke each one of these squares that I'm drawing is a 1 by 1 square, and a 1 by 1 square has an area of 1 square unit. So this is kind of stupid doing it this way. And so this rectangle that's 4 by 9, it can be broken up into 36 squares that are 1 by 1. So 36 squares that are 1 square unit each. And so the area of this rectangle we'd say is 36 square units. I don't have units on the numbers, but when I do area, I have to have square units in my answer. And another way to write square units, if you don't want to write the word square units, is to take whatever the unit is, like feet or inches, and put a squared symbol next to it, and that would be square units as well. So again, it's like perimeter, you don't need formulas for. Adding up the sides isn't that particularly hard to do. But trying to take a figure and make it, cut it up into rectangles, that's nearly an impossible task. So for two-dimensional shapes to find their areas, I'm just going to use these formulas. And we'll go through the problems and figure out how the formulas work and what they are. So there's a triangle, a parallelogram, a rhombus, which is kind of a square without right angles. On a rhombus, all the sides are the same. A rectangle, a square, a trapezoid, and a circle. And I will use the formulas and talk about the shapes as I get into the little homework problems that we have. Imagine I have an example before the homework problems. So first example, this is a trapezoid. Trapezoids, what they have is they have one pair of sides that are parallel. So those two sides are parallel, and then the other sides aren't parallel. If all 4 sides are parallel, then it becomes a parallelogram. So the area formula for a trapezoid is b plus b times h over 2. The h is the line that connects the parallel sides. So the h would be the length of the line that connects the parallel sides. So in this problem, the height is going to be 6 feet. The big B and the little b are the lengths of the longer and shorter parallel side. The big B is the length of the longer parallel side, so for this problem, big B is going to be 9 feet, and little b is the length of the shorter parallel side, and in my problem, little b is 4 feet. So if I want to find the area, I'd go A for area equals, form a fraction. In the numerator of the fraction, I get a parentheses. I put, for big B, I'm going to put 9 feet. For little b, I'm going to put 4 feet. I'm going to close my parentheses, and then for h, I'm going to put 6 feet. And the denominator of the formula has a 2. Inside the parentheses, I need to do that first. When you're adding, you don't get square units. So inside the parentheses, I'll get area equals 13 feet. When you're adding, you don't get square units. When you multiply, you get square units. Times 6 feet over 2. Now in the numerator, I'm going to multiply the 13 and the 6. I could cancel the 6 and the 2. That probably would be better. But when I multiply 13 times 6, you get 78. And when you multiply feet times feet, you get square feet. And you can write the word square feet, or you can write a feet symbol with a square, a 2 exponent. Or there's got to be abbreviations for square feet that I might use too. Haven't divided by 2 yet. I'm going to finish up dividing by 2. I think that comes out to 39. So my answer for the area of this trapezoid is going to be 39. And then I'm going to write a feet with an exponent of 2 to represent square feet. You could write the word square feet. And if you wrote SQ period FT period, that would stand for square feet as well. And that's exactly what I did on the next page. I did this exactly the same way, did exactly the same thing. So I need an area formula for parallelogram. Here I'm assuming opposite sides have the same length, and I'm assuming opposite sides are parallel because they look parallel. So the area formula for a parallelogram, you'll notice that it only has 2 figures. It has a B and it has an H. And an H is the line that connects one of the parallel sides, and the B is the length of the parallel side that the height connects. So the formula for this, area equals base times height, where the height, again, it's the line, the length of the line that connects one of the sets of parallel sides. So the height actually could go this way too. And the B is the length of the side that the height touches. So in my problem, I'm not going to use these 7s because the 7s aren't part of the formula. The sides that are part of the formula are the lengths that are part of the formula is the height, which is the dotted line that connects the 2 sides, and the length of one of those sides. So for this problem, my area is going to be the base, which is an 8 centimeters, times the height, which is a 4 centimeters. When you multiply units, you get square units. When I multiply 8 times 4, I get 32. So my answer for this is the area is going to be 32 centimeters squared. I could write the area equals 32 square centimeters in words as well. Usually I'm going to use A for area and P for perimeter, C for circumference, rather than writing out the word area. And usually I'll abbreviate my units. Perimeters, you shouldn't get squares in your units, but areas you will get square. Area of a circle is not a new word. Circumference is the perimeter of a circle, but the area for a circle, we need the area formula, and the area formula for the circle is pi r squared. This problem says find the area of a circle and leave your answer in terms of pi. So my area is going to be A equals pi times 2 inches squared. And when you square inches, when you square the 2 inches, you're really multiplying 2 inches times 2 inches, because squaring something means to multiply it by itself. I'm going to go right to my answer. I'm going to multiply the 2's together and get 4. I'm going to leave the pi, and inches times inches are square inches, and I like writing my inches with an exponent rather than writing out the word square inches. So that would be perfect answer for finding the area of that circle. And you'll notice that I took the time to write in words and in symbols, and I used the word area instead of A. So any of those answers, usually a lot of the problems that we will get, well, we may get a problem that asks for both area and perimeter, so you somehow need to designate area with some sort of symbol that I can tell that it's area, and perimeter, so I use A for area and P for perimeter. Homework problems. Find the area of a triangle. Well, the area of a triangle, the formula for a triangle, area equals base times height over 2. And just like the height of parallelograms and trapezoids, a height is not part of the perimeter, but it's one of the lengths that connects it's a length that goes from one of the vertices or one of the corners of the triangle to the opposite side that forms a right angle. So in my problem, the height of this is going to be 6 centimeters, and the base is always the side that the height connects to. So my base is going to be 14 centimeters. And in problem 14, my area is going to be base 14 centimeters times height 6 centimeters over 2. It's probably better if I just divide first. So I'm going to go 2 goes into 14 7 times. The 2 turns into a 1, so I don't need a fraction anymore. In the numerator, I have 7 centimeters times 6 centimeters. 7 times 6 is 42. And centimeters times centimeters are square centimeters. So for an answer to problem 14, I'm going to say the area is 42 square centimeters. And then your 13 should work similarly. 15 and 16 are triangles that the height is not inside, it's an external height. And that's not uncommon, but it's not as common. Your triangle in problem 15, its base is going to be 14, and its height is going to be 10. Mine, it tells me what the base and the height are, so I didn't have to be as clever when I do problem 16 as you might have had to with problem 15. But heights can be external, and usually if heights are external, there's dashed lines that indicate the height. So this is the triangle that I'm talking about, and from this corner, if I tried to get to that line and it has to meet that line with a right angle. If I try to meet it with a right angle, the right angle line misses the line, so I had to extend the base to figure out what the height is. So again, area of a triangle is base times height over 2. So for my triangle, the area is going to be base, which is 5 inches. I'll use parentheses for times the height, which is 8 inches, over 2. I could multiply 5 times 8 and get 40, then divide and get 20, or I can cancel this 2 with this 8. The 2 becomes 1, the fraction goes away, the 8 becomes 4. Now I'm going to multiply 5 times 4 and get 20, inches times inches and get square inches. So the area in problem 16 is going to be 20 square inches. So in problems 17 and 18, this side right here is going to be a height because it connects from one vertex to another side with a right angle. This side's going to be a base. It says assume the units are given in inches. So in my answer, eventually I'm going to say the area is something in square inches because all my area computations should have units. In this problem, I don't know what the height is, so I'm going to use the a squared plus b squared equals c squared Pythagorean theorem. This is going to be my a, that's going to be my b, this is going to be my c. So first I need to find what a is. A is the height, and a is also an a from the Pythagorean theorem. Because this is a right triangle, the Pythagorean theorem holds. So I'm going to go a squared plus b squared, which is a squared plus 12 squared, which is 144. Equals c squared, which is 13 squared, which is 169. Now I'm going to minus 144. This is going to give me a squared equals to 25. And then I'll square root, and get a equal to 25. A equal to 5. Now I can find the area. So for my area, it's base times height over 2. My base is 12. My height is a, which is 5. So my area is going to be base 12 times height 5 over 2. Easiest just to cancel this 12 with this 2 and make this 6 times 5 over 1, which will just be 6 times 5, which is going to be 30. And I didn't use any units in any of my computations, but because it says the units, the length of the sides were in inches, I knew that my answer had to have those units, and they had to be square inches, because in area you always have square units. My problem and your problem are essentially the same. You can tell I got yours from mathwarehouse.com. First I'm going to find B. So I'm going to, or first you're going to find T. I'm going to start off by going 9 squared plus B squared equals 15 squared. So I'm going to get 81 plus B squared equals 225. And then minus 81 minus 81, B squared equals 144. So B is the square root of 144. So B is 12. It's technically 12 centimeters because I want the units to be centimeters. So now this is going to be my height. This B is going to be my base, which is 12 centimeters. And so my area is base times height. Base, if I want to put the units in that I'm applying to this problem, are 12 centimeters. Height is 9 centimeters. And then divide by 2. I'm going to take the 12 and the 2 and divide it and get a 6 and a 1. Fraction's gone because it only has a 1 in the denominator. I'm going to multiply the 6 times 9 that's left in the numerator and get 54. And centimeters times centimeters are square centimeters. So for number 20, my answer should be 54 square centimeters. 22 is a parallelogram. The area formula for the parallelogram is area equals the base times the height. This is the height, and the base is the side that the height connects to, so this is the base. The opposite side, the side that the height doesn't connect to, doesn't come up in my computation. So the area for this is going to be the base of 15 centimeters times the height of 5 centimeters, and then 15 times 5 is 75. Centimeters times centimeters is square centimeters, so my area is going to be 75 square centimeters. Another parallelogram, the area formula is base times height. If you can't read yours, this is 6.2 centimeters for the height, 10.3 centimeters for the base. You probably need your calculator. For me, this is my height, this is my base. Area is going to equal 15 inches times 8 inches. 15 times 8 is 120. Inches times inches are square inches. So my answer for 24, the area is 120 square inches. 26 is a parallelogram. The formula for the parallelogram is big B plus little b times the height over 2. The height is the distance that connects the parallel sides. The little b is the shorter of the parallel side. The big B is the bigger of the parallel sides. Again, yours might not be readable. Let me blow it up. So for your sides, one of the sides is 10.6 meters. Use M for meters. The big B is 13.4 meters, and 7.2 meters is the little b. So for me, I'll put the units, I can put the units in at the end because I don't like working with the units. So big B, which is 8, plus little b, which is 4, times the height, which is 5, over 2. This is going to be 8 plus 4 is 12, times 5 over 2. I can divide the 12 and 2 and get 6 and then multiply by 5, or I can go 12 times 5 is 60, and 60 over 2 is 30. When I go to write my answer, even though I didn't use units in my computation, my answer should have units because the problem has units. and in area, you get the units squared. So here the area is going to be 30 square centimeters, or 30 centimeters squared. 28's a trapezoid on its side. This is 14 is going to be the height. 6 is going to be the little b. 16 is going to be the big B. And your trapezoid is oriented regularly. You're not going to need these sides. You'd need those for the perimeter, but not for the area. So for me, area is going to be big B plus little b. So 16 inches plus 6 inches times the height over 2. So it's going to be 22 times 14 over 2. The 2 can cancel with the 14, and it can cancel with the 22. I'm going to cancel it with the 14. So I get 22 times 14. What's that? 154. I'm afraid. 22 times 14. Whoops, 22 times 7. Oh, you get 154. So my area is going to be, the number is going to be 154, and my units are going to be square inches. Really, I think they're kind of overkilled on these. So here, area is going to be big B, which is 6 centimeters, plus little b, which is 2.5 centimeters, times the height, which is 5 centimeters, over 2. This is going to be 8.5 times 5 centimeters over 2. 8.5 times 5 is going to be 42.5. So I get 42.5 over 2, which is 21.25. And I'll put my units in, even though I didn't carry my units through my computation. I can put them in my answer without, because I know what the units are going to be. Your units are going to be square meters. Really? Okay. Getting very tired of doing these. I can't imagine you aren't. So this square, this rectangle you have is 9 centimeters by 16 centimeters. The area formula for the rectangle is length times the width. Doesn't matter which side you call length and which side you call width. You're just going to multiply the two sides. I'm going to call the length the 12.6 centimeters, because if you have to pick, and you can, usually the length is longer and the width is shorter, but it really doesn't matter. I'm probably not even that consistent when I do that. So 12.6 times 6.4, and I get 80.64 centimeters squared. Yeah, I think I got a little bit over anxious. I gave you too many problems here. There's one more kind of problem that we're going to get, but it's not here yet. 34 is a square. The formula for an area of a square is just side squared, and each side here is 5 centimeters, so it's going to be 5 centimeters squared, and 5 centimeters squared is 5 centimeters times 5 centimeters, and so I'm going to get an area is 25 centimeters squared for problem 34. Circles. Circles, the area formula is pi r squared. 2 pi r is the circumference formula. So here in problem 36, my area is going to be pi times 6 centimeters squared, which is pi times 6 centimeters times 6 centimeters. That's going to be 36 for the number. I'm going to leave the pi because I wasn't told to put pi in as a decimal, and centimeters times centimeters are centimeters squared. In 38 as well as 37, you have the diameter is 8 inches, so the radius is half of that, and half of 8 inches is 4 inches. I need the radius for the formula. So my radius is going to be pi times 4 squared. 4 squared is 4 times 4, which is 16. So my area is going to be 16 pi. I need units. That double mark, that stands for inches. So I could write SQ inches if I want to, or I could say the area is 16 pi inches squared. And I'm not sure how to make that into a square, so I can't probably leave that symbol in my answer. I don't know that there's a nice way to make that into square inches. Ugh, finally, last one of this kind of problem. And then we get into the new kind of problem. So in 40, the diameter is 58. So the radius is half of 58. If you divide that by 2, you get 29. So my radius, my area is going to be pi r squared. So it's going to be pi times 29 squared. And I'll put the units in at the end. For 29 squared, I'll type the 29. And I'll hit the x squared key, which is a little bit under the math key. And that gives me 841 pi. And then I'll put square centimeters. So that's the end of the easy area problems. And then we're going to get into another kind of problem, which is a shaded area problem. And these aren't that hard, but sometimes they're kind of clumsy. So the next group of problems wants me to find the area of a shaded region. To find the area of a shaded region, we can do this in 2 steps. And one of the areas I need to find is the area of the unshaded region, and let me do that first. I kind of go in an opposite order from what I said. So for this, to find the area that's shaded, first I'm going to find the area of the unshaded region. And now it finally tells me to use 3.14 for pi and round my answer to 2 decimals. So first I'm going to find the area of the unshaded part. That's a circle. Its radius is 8. So the area would be pi times 8 inches squared. I was told to use 3.14 for pi. So I'm going to get 3.14 times 8 inches times 8 inches, and using my calculator, 3.14 times 8 times 8 gives me 200.96 square inches for the unshaded area. The next thing I'm going to do is shade the whole shape in. I'll find the area if the whole shape was shaded in. So find the area if there were no unshaded part. And then I had to get a little bit clever. I have to realize that in any direction from the center of the circle to the edge of the circle, there's 2 radiuses, and these 2 radiuses are going to give me 16 inches in any direction. So the unshaded, if I color in the unshaded part, what I have left is a square that's 16 by 16, and the area for a square is going to be side squared, so it's going to be 16 inches squared, which is 16 inches times 16 inches. I think that's 256, but I'm not really to commit to that. So that's 256 square inches. And then I'm almost done. The shaded area is going to be the difference between the area if the whole thing's shaded in minus the unshaded region. So my answer is just the difference of these two. The area if the whole thing was shaded in, which is 256 square inches, minus the area that wasn't shaded, 200.96 inches squared, and that difference, and you can't see what I'm doing anymore, is the shaded area. So basically I'm taking the entire area subtracting out the unshaded area, that will give me the area that's shaded. And so 256 minus 200.96, and when you subtract, the units don't change. So the answer to this, the shaded region in the given graph is 54.04 inches squared. And I'm going to be very consistent. I'm going to do that the whole way down. I'm going to find, when I get a graph that's partially shaded, partially unshaded, I'll find the area of the unshaded part, keep that number in my mind, shade the whole figure in, find the area as if the whole figure was shaded, and then subtract the two amounts. It's always a bigger minus a smaller. Homework problem. So problem 41 and 42 are going to work the same. And for me, first, I'm going to find the area of the unshaded part. And my unshaded part is a square that is 5 meters by 5 meters. And an area of a square is side squared. So my unshaded part is going to have an area of 5 times 5, or 25 meters squared. So that's first. Second, I fill in the shading, fill in the unshaded part, and I find the area of this whole figure, like it's all shaded in. And this whole figure, when it's all shaded in, becomes just a rectangle that's 14 by 9. So I'm going to find the area if it was all shaded. And if the whole thing was shaded, I'd be asked to find that area, and that's a rectangle. And an area of a rectangle is just multiplying the two sides, the length times the width. Doesn't matter what you call each side, you just multiply the two sides. I think I get 126 meters squared. And then I finish up by subtracting. Let me make sure that 9 times 14 is 126. So my answer, the shaded area that I'm asked to find, is the 126 meters squared minus the 25 meters squared, and my answer is going to be 101 square meters. For your problem number 41, it says when you're finding the area of the circle using the pi r squared formula, to use 3.14 for pi and round to 2 decimals. All right. On yours, you can't really see this, but I'll blow it up so you can see it. The inside circle has a radius of 5, and all the way to the edge, it has a radius of 10. So I'm assuming that in mine, the unshaded region's in the center, and yours, the unshaded region's in the center. So when I do problem 44, first, I find the area of the unshaded region, which is the center part. And that unshaded region, this circle here, is a circle with a radius of 7. So the area is going to be pi times 7 centimeters squared. And it tells me to leave my answer in terms of pi. So I'm going to get 7 squared, which is 49 pi centimeters squared. Then pretend the whole thing was shaded in. And if the whole thing was shaded in, I like it all the same color, just some, I don't know if it helps, but if the whole thing was grayed in, then that would be asking me to find an area of a circle with a radius of 14. So the area, if completely shaded, would be pi times 14 centimeters squared, because that would be a circle of 14 centimeters. And I think is that 196, 14 squared? Yeah. So my area, if it's completely shaded, would be 196 centimeters, 196 pi centimeters squared. And for my answer, I'm just going to subtract. So I'm going to take 196 pi centimeters squared minus 49 pi centimeters squared. The pi's don't cancel. They work like x's, like 5x minus 3x is 2x. 196 pi minus 49 pi is going to have a pi in it. If I do 196 minus 49, I get 147. So my answer, the number part is going to be 147. I'm going to have the pi, and the unit part is going to be centimeters squared. Hopefully these are going okay. Sometimes when I test on these, they're a little bit clunky. My problem 46 is harder than your 45. My unshaded area is easy. My unshaded area is a circle, is a rectangle, idiot. And on yours, I'm assuming this is a square that has a side 7. So my unshaded area is going to be 6 by 8. Eventually I'm going to put square meters in my answer, but I don't want to mess this up. So it's 6 times 8. So my unshaded area is 48. In order to find my shaded area, if I shade this whole thing in, I get a circle. So I want to find the area of this big circle if it was all darkened in. And in order to do that, I need to know its radius. And its radius is going to be half the distance, it's the distance from the center to one of the sides. I'm going to find this length right here, which is given in your problem, and cut it in half to find the radius. And to find this length, I'm going to use a squared plus b squared equals c squared. So I'm going to do work that you don't have to do on yours. I'm going to find the radius because it's not given. To find the radius, first I'm going to find the diameter, which is actually the c in this rectangle. So the circle that's drawn in mine has a diameter of 10, so the radius is halfway across, which is 5. So now for my shaded area, if the whole thing was shaded, I would be finding the area of a circle that has a radius of 5. And I'm told to use 3.14 for pi. So area is pi r squared, and in for pi, I'm going to put 3.14. In for r, I'm going to put 5. So this is going to be 3.14 times 5 times 5. And when I do 3.14 times 5 times 5, I get 78.5 square units. So if the entire thing was shaded, it would have an area of 78.5 square units. And now I'm going to subtract. To get my answer, I take the area if the entire unit figure was shaded minus the area of the unshaded region, and I'm going to attach units to this. So it's going to be 30.5, and then it's going to be meters squared. Meters is an m, and then squared for square meters. Your units are going to be square meters as well. Both of our problems in 47 and 48, we have to find the diagonal, which is going to help us get the fully shaded. So, but for the unshaded part, in both of ours, they're squares. So the unshaded area in problem 48, as well as 47, using area is side squared, and 1 squared is going to be 1 square unit, and it's actually going to wind up being 1 square meter for the unshaded area. Now I'm going to find the diagonal. My diagonal is a C, and I'm going to use this triangle right here, and I'm going to go for my diagonal, which is going to be twice, I divide it in half for the radius. So my diagonal is going to be 1 squared plus 1 squared equals c squared. That's 1 plus 1 equals c squared. So 2 equals c squared. So the square root of 2 equals the square root of c squared. So c equals, and I'm just going to round to 2 decimals, even though rounding early makes bad things happen in terms of my accuracy, but I'm being consistent with myself. So I'm going to say c is 1.41, and to find the radius, that's c is the diagonal, has a length of 1.41. So the radius of, if I color this whole thing in, I'm finding the area of the big circle, and I need its radius. Its radius is going to be 1.41 divided by 2. And so the radius that I'm going to use is 0.71, rounding that to 2 decimals, just to be consistent with myself. Rounding everything to 2 decimals, definitely not something you do in a chemistry class or in a physics class, but in a Math 142 class, we don't need that precision. So now I'm going to get the completely shaded area, and if the whole thing was completely shaded, I would be finding the area of a circle with radius 0.71, and I'm going to use pi for 3.14, and then I'm going to do 0.71 squared, and so 3.14 times 0.71 squared. So I hit the squared key rather than doing times 0.71 twice. So that big circle has an area of 1.58, and the units are meters squared. So I found the unshaded area, I found the area if it was all shaded. Now I'm going to subtract. So for my answer, I'm going to take the big number, 1.58 meters squared, the area if the whole thing was colored in, minus the unshaded area, which is 1 meter squared, and I'm going to get an answer of 0.58 meters squared. I came into this lecture thinking it was going to be short, and sorry it didn't turn out that way. I was like, oh, this is going to be a short, quick, easy morning, and it's feeling like it's really dragging, so I'm completely sorry about that, but we're close to the end. This feels just like the first problems. So for 50, I'm assuming my units are in centimeters, so the unshaded area is going to be side squared, so it's 5 squared, so it's going to be 25. If I want units, it's square centimeters. If I shade this in, then the completely shaded area is going to be a bigger square. It's 13 by 13, so the area of that's going to be 13 times 13, which is 169. I'll attach my units. My units have to be square units because it's area. And now I'm going to subtract the completely shaded area minus the unshaded area. And I get my answer. The shaded area in problem 50 is 144 centimeters squared. Still feel a decent number of problems. 1, 2, oh, just 2 more. Okay, so for me, I need to find the unshaded area, which is a square. That's 2 centimeters by 2 centimeters. So it's going to be 2 centimeters squared, which is 2 centimeters times 2 centimeters, which is 4 centimeters squared. And then if this whole figure was shaded in, it would look like that. And then the completely shaded region is a triangle. And the base and the height are both 4. Here's the base of 4 centimeters, and here's a height of 4 centimeters. I had to add the sides. Now let me blow yours up so you can see the numbers real quickly here, just in case you couldn't see these numbers. So this was 8 centimeters. This thing down here was 30 centimeters. That makes this length right there the difference between 30 and 8. So part of your square, part of your rectangle has 12 centimeters. This whole length is 15 centimeters. This small length is 4 centimeters. The difference between 15 and 4 is 11. That's going to make that 11 centimeters. So when your unshaded area is 11 by 12. So those are the figures you're going to need in your drawing. Back to my drawing, I haven't did the completely shaded area. That's a triangle, and the area is base times height over 2. Base is 4 centimeters, height is 4 centimeters, and then over 2, that's going to be 16 centimeters squared over 2, which is 8 centimeters squared. And then for my answer, I subtract. So for my answer, I take the completely shaded region that has an area of 8 centimeters squared minus the unshaded region whose area was 4 centimeters squared, and 8 minus 4 is 4, and when you're subtracting, the units don't change. So I get the shaded area in my triangle is 4 centimeters squared. '53 and 54 work more or less the same. Not that you can read yours, but your circle is going to have a radius of 6, and this figure is a square. It's 6 halfway across, 12 all the way across. Mine is similar, but mine is worse, because in mine I have the, I'll get a fraction. So what I'm going to do for the unshaded area is I'm going to take these two circles and flip them together, and my unshaded area is just going to be the area of that circle. Yours too is going to be a whole circle. So you have 2 half circles, and the area of 2 half circles gives you 1 whole circle. Wow. Clearly I'm wearing out. To do an unshaded area, I need the area is pi, which I'm going to use 3.14 times r squared. And for my r, if the whole way across the square is 11 inches, my r is going to be 11 over 2, which is 5.5 inches. So my area for my unshaded, or for the circle, is 3.14 times 5.5 squared. I'll put the units in at the end. So if I do 3.14 times 5.5x squared, the unshaded mine is 94. I'll round it to 99 because it says around to 2 decimals. So my unshaded area is going to be 94.99, and then my units are inches squared. And then if this whole thing was shaded in, I would be finding the area of a square that's 11 by 11. So my completely shaded area is going to be 11 squared, because area of a square is side squared, and that's going to be 121, and it's going to be inches squared. So to get the answer, or the shaded area in the original problem, I take the 121 inches squared minus 94.99 inches squared, and you subtract, the units don't change, so I'm going to get square inches, and then I'll do 121 minus 94.99, and my calculator tells me it's 26.01 inches squared. So that should take you through the section. Hopefully it went well. I know that historically in the past, students haven't done well on the shaded area problems, and I taught them a little bit differently this semester, so hopefully they feel okay. But if they don't feel okay, I can make up more problems for you just to make sure you have those perfected.